Hello everyone and welcome to day 23 of Jamb Mathematics in 30 days. It has been an wholesome series so far. I want to say a very big thank you to each and every one of you that has been part of the series from day one up until this moment. It has been an interesting one so far, and I'm sure that you've been learning a lot as we go on with the series. Please take note that I will still want to hear from you. So if there's any aspect that we did not touch on any of the topics we've treated so far, you can put that part into the comment section or just ask a question in the comment section. If there's anything you would like us to know about, please also put that in the comment section and we will definitely attend to every one of your comments. And also please, if you're coming across this video for the first time, well, this is Jamb Mathematics in 30 days brought to you by Oya Learn. And we believe that when you dedicate 30 minutes to 45 minutes of your time daily to these videos, you should have everything it takes to get you properly prepared to face Jamb Mathematics and come out in flying colors. So if you are one of those who is dreadful of Jamb Mathematics, well, say no more. Just follow the series from day one to this time, and I promise you, you will do absolutely well in the Jamb exams. Now, day 23 is about probability, and many of us are familiar with probability, and what we usually think of when we think probability is just the equation for probability, where we know that the probability that an event should occur, it means that, like when I say probability of an event A to occur, it means your number of expected outcome over total outcome. Now, in most cases when we are dealing with probability, we know there are just two types of probability. We have the experimental probability and the theoretical probability. For the experimental aspect is when the event has been carried out already and you can see the outcome for each of those events, and then you are asked to calculate probability of one of them occurring in future. So that one will be experimental. But in a theoretical case, it hasn't really happened. You're just working based on information you know about such kind of events, right? And then you work with that and then calculate the probability of that event occurring. Now, one thing you should also know that when the probability of an event occurring is 1, it means that it will definitely occur. And then when the probability is 0, it means it will never occur. And know that probability ranges from 0 to 1. It cannot surpass 1 and it can never be less than 0. So if you are solving any problem in probability and you're finding your answer in the negative range or it is greater than 1, then there must have been an error in your calculation. And as far as Jamb goes, what is expected of you is that you should be able to solve problems involving probability, including the addition and multiplication rule. However, they keep it as simple as possible due to the nature of the exam. You know, it's a multiple choice question and you are only allotted a little amount of time. So they try as much as possible to keep it as simple as possible. So we'll only be looking at probability that involves addition, multiplication, and just general theoretical probability, as well as the experimental probability. So if you're ready, let's just go on now to solve past questions in Jamb on probability. So to start with, this question from 2006 says, a bag contains 5 black, 4 white, and X red marbles. Now, if the probability of picking a red marble is 2 over 5, find the value of X. So to solve this, this is how we'll do this. This is the direction to go to solve. Now, first off, we know that the probability of picking a particular marble out of this set of marbles is number of expected over number of total. So we already know that we have black balls, that is 5. We have white to be 4. And then we are told that red is X. Okay? So total marbles would therefore be 5 plus 4 plus X, which will give us 9 plus X. Right? So the probability of selecting a red marble. Originally, from this should be number of red marbles, which is x, over total number of marbles, which is 9 plus x. But we are also told that that probability is given as 2 over 5. So we can then equate this to 2 over 5 and then solve for x using these two expressions here. So from here, we can then cross multiply and say 5 times x, which will give us 5x equals 2 into 9 plus x. So from here, 5x equals 2 times 9 would give us 18 plus 2x. Now, collecting like terms, 5x minus 2x would give us 18. So this means 3x is 18. Now from here, when we divide both sides by 3, so 3x divided by 3 becomes 18 divided by 3, so x is 6. And the option that has 6 is D. So that's our answer. This question says the probability of picking a letter T from the word obstruction is. This is one of those questions you can solve very fast within 3 to 4 seconds. So in your solution, all you have to factor is this. The word obstruction has how many letters? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? And then T appears 2 times. Right? So the probability of picking T, so probability of T would then be 2 over number of total outcomes, which is 11. So our answer is B. However, if you look at this question here, we have the word obstruction written with letters that are all in uppercase. Now, sometimes you could face a question where one or more of the letters are in uppercase while the rest are in lowercase, in such a way that the letter you are finding the probability of picking will appear in uppercase and also in lowercase in the same word. So when you have that kind of a case and you have to solve the probability of picking such a letter, now what you focus on is the one you are finding the probability of, whether it is the one of the uppercase or the probability of picking the one in lowercase. So for example, if I were dealing with letter O and this was uppercase O and the others are in small letters, that is lowercase, and I'm finding the probability of picking the lowercase o, I'm only going to focus on this one. That is 1 over 11. It won't be 2 over 11 like in this case. So just watch out for that. Though most of the times, it is always written in uppercase. I hope that clears it up for you. Let's go to the next question. This question is on experimental probability. And we see this table and we are told that the result of rolling a fair die. Now, a fair die means that all the faces of the die have equal chances of occurring every time you roll it. So when the fair die was rolled 150 times, the result is summarized in this table. So we have to find the probability now of obtaining a 5. Now, one thing we know is that the sum of everything here should be 150 when you sum all of this. So we'll start with that. Solution. Now, because we are working for 5 here, we see we have x here, so we actually have to solve for x. So let's sum everything here. 12 plus 18 plus x plus 30 plus 2x plus 45, all is 150. So let's add them up. X plus 2x will give us 3x. And then 12 plus 18, that would give us 30. 30 plus 30, and we have 60. Now, 60 plus 45 will give us 105. So 3x plus 105 equals 150. So from here, we can say 3x equals 150 minus 105, and that will give us 45. So divide by 3, and then this implies that x equals 5. So we have 15 for x. So now the probability of obtaining a 5, probability of 5 occurring will be, how many times does 5 occur? We have 2x, so 2 times, what is x? 15 over the number of times that the die was rolled, so we have 150. Now this will give us 30 over 150. So of course 0 cancels 0, 3 here 1, 3 here 5. So 1 over 5 is our answer. So we pick B. Since we are still solving probability, you might want to ask yourself, what is the probability that you are going to ace Jamb mathematics when you study with Oyalen? Well, your probability is 1. And you can always get even better by also practicing with the Exam Fun app. Go on and download the app from the Google Play Store and the Apple Store to improve your math skills and also earn as you learn. Now let's solve this question from 2009, which says the probability of a student passing any examination is 2 over 3. If the student takes 3 examinations, what is the probability that he will not pass any of them? So in this case, we are given the probability that the student will pass an exam. But the question is asking for the probability that he will not pass any of the 3 exams he writes. So we have to find the probability that he will not pass one of them first. So if the probability of pass equals 2 over 3. So probability that he will not pass would then be 1 minus 2 over 3. So we can write this as 1 over 1. Now, when we take LCM, we get 3. LCM of the denominator in that case is 3. So 1 and 3 is 3. 3 times 1, we have 3, minus 3 and 3, 1. 1 times 2. So what we have here is 3 minus 2, which is 1, over 3. So this is the probability that I will not pass one of the exams. But the question is the probability I will not pass any of the 3 exams. So we go on to say probability of not passing any of 3 exams. Now that will be 1 over 3 for the first one, multiplied by 1 over 3 for the second, multiplied by 1 over 3 for the third. Now this would give us 1 times 1 times 1, which is 1, over 3 times 3 times 3, which is 27. So our answer is 1 over 27. D. The table above shows the distribution of marks of students in a test. Find the probability of passing the test if the pass mark is 5. So when we look at the table, we see the marks from 2 all the way to 9. And then the number of students that scored each of those marks. So from 2 marks, we have 3 students. 3 marks is 4 students, and on like that. And we know that the pass mark from the question is said to be 5. So when we're looking for probability of passing this test, we'll consider from mark 5 all the way to mark 9. And we have the number of students there from 0, 4, 5, 2, and 1 respectively. Right? So let's solve. To solve this, we'll start by saying numbers of students that passed the test. Now that will be from here, so 0 plus 4 plus 5 plus 2 plus 1. Let's add up. This is 9, then that's 12 altogether. So when we add that, we get 12. Now, total number of students in the test. Now we add everything we have here, so that will be 3 plus 4 plus 1 plus 0 plus 4 plus 5 plus 2 plus 1. And that gives us, now this is 12, so plus 8, we have 20. Now, probability of passing would be number of expected, which is 12, over total outcome, which is 20. So they are both divisible by 4. So 4 in 12, that is 3. 4 in 20, that is 5. So the correct answer here is A. Now, in this question, we're told if 3 unbiased coins are tossed, find the probability that they are all heads. Now, by unbiased coin, they mean that each side of the coin have equal chances of occurring. That is, you could either get head or tail. They have equal chances, half and half. Okay? And 3 coins are tossed. So we want to find the probability that all 3 will land on heads. So to do this, You can either solve it by taking it as one coin tossed 3 times and then you see the collective outcome, or you use your binomial expansion to solve it. If you're good with binomial expansion, that will work very fine as well. But let's apply it when you have just one coin tossed 3 times. So during the first toss, you should have heads, then tail. Then this will give you heads, tail. This will also give you heads, tail. Now to the third one, we'll have heads, tail, head, tail, head, tail, head, tail. Now, what you should know is that the number of outcomes you have at the end is the same thing as when you take 2 to the power of the number of coins. So 2 raised to the power of 3 will give us 8. Now I'm saying 2 because there are only 2 outcomes, so head or tail. So 2 raised to the power of the number of coins we are working with, which is 3, would give us the number of outcomes we should have. So let's see what the outcomes are. So for outcomes, at this point we have head, head, head. So let's put that down. These are outcomes. So head, head, head. Now head, head, tail. Now head, tail, head. Then head, tail, tail. Now to this tail, head, head. Tail, head, tail. Then tail, tail, head. And then finally tail, tail, tail. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 outcomes. Now the question itself says, what is the probability of getting all heads? So the only case where we have all heads is this. So our probability of heads would be 1 out of 8 outcomes. So 1 over 8. The correct option is D. Now, this question was set in 1990 and then repeated in year 2021. And it says, 2 numbers are removed at random from the numbers 1, 2, 3, and 4. Now, what is the probability that the sum of the numbers removed is even? So, to get this, one of the best ways to solve it is to first create a table like this. Now, we're going to have 1, 2, 3, and 4. So let's break it. Then 1, 2, 3, and 4. Now, let's get all the outcomes. You could pick 1 the first time, and then when you return, pick 1 again. So you would have 1 plus 1, which will give you 2. Now, 1 plus 2 would give us 3. 1 plus 3 will give us 4. 1 plus 4 will give us 5. Now 2 plus 1, that's 3. 2 plus 2, that's 4. 2 plus 3, that's 5. 2 plus 4, and that's 6. Now 3 plus 1, 4. 3 plus 2, 5. 3 plus 3, 6. 3 plus 4, 7. 4 plus 1, 5. 4 plus 2, 6. 4 plus 3, that's 7. And 4 plus 4, that's 8. Now, let us circle out the even combinations. So this is even, 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 and even. So probability of even combination would then be, now expected outcome, that is 1, 2, 3, 4, 5, 6, 7, 8. 8 out of the total outcome of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 8 out of 16. Now breaking this down to the lowest term would be 8 in 8, 1. 8 in 16, 2. So our answer is 1 over 2, which is option C. Now, this question, originally set in 1990 and then repeated in 2021, says to find the probability that a number selected at random from 41 to 56. Now, that is, it includes 41 and 56 and the numbers between them. And we have to find probability that the one selected at random is a multiple of 9. So solution. Let's bring out everything within this range first. So that is, the numbers we are dealing with are 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, and 56. Now, which of them are a multiple of 9? Now, the first one we come across is 45, because 9 times 5 would give you 45. And then the next one is 9 steps away. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the next one is 54. So now we have 49 and 54. Those are the multiples of 9 that we have here. So the probability that what we have is a multiple of 9 would then be these two, which is the expected, over the total outcome. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 2 over 16. Now 2 in 2, that is 1. 2 in 16, that is 8. So our answer is 1 over 8, option A. Now let's find the probability that a number selected at random from 40 to 50 is a prime. Now we recognize that prime numbers are numbers that are only divisible by 2 factors, which are 1 and itself. So let's first list out numbers from 40 to 50. They consist of 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers in total. Now, of all these numbers, the ones that are prime numbers are 41 is a prime number, 43 is also a prime number, and then 47 is a prime number. So we have 3 prime numbers from 40 to 50. So the probability of selecting a prime number would then be number of expected, which is 3, over total outcome 11. So the correct answer is C. This question asks, it starts by saying a fair coin is tossed twice. Now, what is the probability of obtaining at least one head? So we're going to solve this using the tree diagram. So it's a fair coin tossed twice. So when the coin is tossed at first, so first toss would produce either head or tail. Now, second toss. Here we have head, tail, head, tail. So our outcomes would be head, 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 tail. Now to this, since we have already paired this with this, now we go to this. So we pair this now. So we have tail, head, and then tail, tail. So in this case, these are the 4 outcomes possible. And the question is asking for the probability of getting at least one head. So the only thing that is out of it is tail, tail, where there is no head. Here we have the first one being head, the second toss being head, first toss being head, second toss being tail, first toss being tail, second toss being head. So these are the ones that have the condition we want, which has at least one head. So the probability in this case would then be expected outcome 3, total outcome 4. And 3 divided by 4 will give you 0.75. So the correct option is B. Now, this question says a coin is tossed 3 times. What is the probability that at least one head is obtained? So in this case, we have to toss a coin 3 times. So let's generate the outcomes from the tree diagram. So take the coin and then toss it the first time. We're going to have either head or tail. This is first toss. Now to the second toss, head or tail, head or tail. Now to the third toss, head or tail, head or tail, head or tail, head or tail. So now let's pick our outcomes. Now looking at what we have here, remember this is third toss. So we have to join all the outcomes from first toss to the last toss. So starting with heads here. So this will be head, head, head. So we write it H, H, H. Now head, head, tail. Now we have completed everything here. So we write head, head, tail. Now we're going to move this way now. So head, tail, head. Then head, tail, tail. Now we move to this, since we have completed this one now. So we go tail, head, head. Then tail, head, tail. Then tail, tail, head. And then tail, tail, tail. So all the outcomes are 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Now of all the outcomes, it's only one that does not have heads in there. Every other one has 1, 2, or 3 heads. And the question is asking for the probability that at least one head is obtained. So our probability for at least one head would then be number of outcomes that have at least one head. That is 1, 2, 3, 4, 5, 6, 7 out of a total outcome of 8. So the correct option to go for here is option A. This question from 2023 says, a bag contains 8 red balls and some white balls. Now, if the probability of drawing a white ball is half the probability of a red ball, then find the probability of drawing a red ball and a white ball if the balls are drawn without replacement. So we see here we are drawing red and white, and then we also have a condition that is drawn without replacement. So let's solve this. Now first, let's start by noting the total number of balls we have. Now we know we have 8 red balls plus a certain number of white balls. So let's call the number of white balls X. So we can go on to say white balls is X and the red balls is 8. Good. So now that we have that drawn out, let's get the probability of each of them. Probability of red ball would be 8 over 8 plus X, while the probability of a white ball would be X over 8 plus X. Now, from the question, we are told that the probability of drawing a white ball is half the probability of drawing a red ball. Okay, so that is, we know that X over 8 plus X equals 1 over 2 8 over 8 plus X. So 2 here 1, 2 here 4. So we have that X over 8 plus X equals 4 over 8 plus X. Since the denominator are equal, so they can cancel out, and we know that X here would be 4. So now we know the white balls are 4. And then the total balls will be 8 plus 4, which will give us 12. So this will now be 12, and this would be 4. We've updated our information now. Now let's find the probability of drawing red and white without replacement. So probability of red and white without replacement. So to draw red, it will be 8/12. Now multiplied by, to draw white, we would have 4 white remaining out of a total of 11, taking that we have drawn red first, right? So this will then be, let's break it down, 4 here 1, 4 here 3. So what we have is 8 times 1, which is 8, over 3 times 11, that is 33. So our answer is D. Now, this question from 2023 says, 2 dice are tossed. What is the probability that the total score of the 2 dice tossed is a prime number? So when you throw 2 dice, you would get a score from each of the dice, and then when you add those together, they are saying what is the probability that by the time you add those together, you get a prime number. So to solve this, we're going to create a grid. Now every die has from 1 to 6. So 1, 2, 3, 4, 5, 6. So the second die too, 1, 2, 3, 4, 5, and 6. Now, so now that that is done, let's now put the outcome inside the grid. So 1 plus 1, this will give you 2. This will be 3, 4, 5, 6, 7. So you see, we are just adding them up like that. So 1 plus 2 would get 3. So following that, we should have 4, 5, 6, 7, 8. Then this will be 4, 5, 6, 7, 8, 9. Then this would be 5, 6, 7, 8, 9, then 10. Then this would be 6, 7, 8, 9, 10, 11. And this would be 7, 8, 9, 10, 11, then 12. Now let's see how many of these outcomes that are prime numbers. Now 2 is a prime number, 3 is also a prime number, 5 is not, 4 is not, so but 5 is. 6 is not, 7 is. 3 is a prime number, 5, 7, 5, 7, 5, 7, 7, 11, 7. Oh, this ought to be 11. So, because 10, 11, then 12. So this is 11. Now, checking this, our expected outcome is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we can break this down with 3. 3 will go in 15 5 times. 3 will go here 12 times. So we have 5/12. That's what we see in option A. This question said in 2024 says the Venn diagram above shows the number of students offering physics and chemistry in a class of 65. That is, the universal set is 65. Now, what is the probability that a student selected at random from the class offered both physics and chemistry if every student offer at least one subject? So we know that there will be no student that does not take either of physics or chemistry. However, we know that there will be some students that take both. So let's call that X. So what we'll have here will then be 30 minus X, and then this will be 45 minus X. So first, let's solve for X. To solve for X, we're going to add everything here and equate it to 65. So 30 minus x plus 45 minus x should give us 65. Now 30 plus 45 gives us 75. So minus x plus x, that's 0. So this minus x stands, equals 65. So from here we can see that x is 75 minus 65, which will give us 10. So now that we know that the number of students that take both is 10, so we can now say this is 10. This will therefore be 30 minus 10, which will be 20, and this will be 45 minus 10, which will be 35. But the question is asking for the probability that a student selected at random offers both of them. So probability of physics and chemistry. Now, that is, if we pick a student, that the student will be within this shaded portion here. That is x. Expected outcome is x, which is 10, over total outcome, which is 65. Now, we see that they are divisible by 5. So 5 in 10 will give us 2. 5 in 65. 5 will go in 6 once, remember 1. And in 15, that's 3. So we have 13. So 2 over 13. That is what we see in option A. This question from 2024 says, a bag contains 7 red and 4 black identical balls. Now, 2 balls were picked at random from the bag and replaced each time. So there's replacement every time you pick. So find the probability that the 2 are of the same color. So if we get what the question is saying accurately, it's either you are getting red or black. Okay, so we have to first find probability of picking 2 reds and then probability of picking 2 blacks. Then you go one at a time with replacement. So first, let's find the total number of balls. So we know that red balls is 7, black balls we have 4. So total will be 7 plus 4, which is 11. So probability of picking red and red would be, now first probability of picking red would be 7 over 11 multiplied by picking the second red would be 7 over, remember we have replaced it, so it will still be 11. Now 7 times 7 gives us 49. 11 times 11 gives us 121. Now probability of picking black and black, that will be 4 over 11 times 4 over 11. And this will give us 16 over 121. Now, probability of picking red or black would then be, so in the first case, we have 49 over 121. Then all means we do plus. In the second case, 16 over 121. So let's add. LCM 121. So we have 49 plus 16. So let's add. 9 plus 6, that's 15. So 5 carry the 1. 1 plus 4, 5 plus 1. And then we have 6. So 65 over 121. Yes, that's in the option. So we go with option B. Now, folks, note that you can always improve your math skills by taking more tests on the Exam Fun app. Now, go on and have fun as you solve as many problems you can on the app, and you can also earn as you do so. So, I'll see you in the next video where we'll be looking at more problems that will help us become better as we go on with Jamb Mathematics in 30 days.